Hello everyone, can you hear me well?
Yes, we can hear you.
Okay, perfect. And do you see my presentation?
Yes.
Okay. So good morning everyone. Today I'm gonna make a small presentation about the valorization of residual energy in the industry. But first I would like to introduce myself. My name is Thomas. I'm native from France and it's my third year of study in Montreal. I'm doing a bachelor in chemical engineering. So now if we go into the presentation, I will start with a small introduction and then I will give the objectives of my internship with Jean-Philippe. Then I will give the theoretical solution that I found in the literature to harvest energy, but I will also give some practical solution I had in my other internship I did this summer in a pulp and paper company, and then I will end with a conclusion. So to start, our society used a lot the linear economy model, which is basically we take raw materials, we use them, and we produce waste. But it's not a good solution because we don't have an infinite quantity of raw materials, and we can produce as waste as we want. That's why scientists came up with another model, the circular economy, which aims to reduce the use of raw materials, but also to reduce the waste production. And the solution to do it is to use the waste as raw materials. But we also have to think about energy in the circular economy because we don't want to lose our energy outside the system. So in Canada, we have the 8 months energy consuming sector that are rejecting 70% of this energy. It's around hundreds of petajoule, which is quite a lot, and it represents 1% of the total primary energy consumption in the world. I know it's hard to visualize petajoule. That's what I came up with some image to show what it represents. It's, for example, the energy released by a nuclear bomb. It's also the total energy consumption of an entire country, Norway, and it could also fill up more than 200 million car tank. If we check the aluminum industry more specifically, it's about 80 petajoule a year, and it represents 20% of the Canadian nuclear production. If we could just have 10% of this heat, it would allow to save around 1 million Canadian dollars and to reduce a lot our greenhouse gases emission. But the main problematic is how do we harvest this energy? That was the main goal of my internship. If we go through the objectives of my internship, I first wanted to check the availability of energy waste in the industry, and then, as I said, find some solution to harvest this energy. Then I wanted to explore the thermodynamic behavior of this solution and also to build a numerical model for one of these solutions. So when we check the industry rejecting heat, we have a lot of industry losing heat to the environment. And as you can see, the steel industry is very nice because it's rejecting heat at a very high temperature. And it's good because the higher the temperature, the easier it is to get this energy. Now, if we go through the solution, we have first the air Brighton cycle. It used the slag. The slag is like a mixture made of impurities coming from the iron ore. To treat the iron ore, it requires a process which is very hot, and the slag is at more than 1,000 degrees Celsius. So the slag will be used to heat air, and this air will go through a heat exchanger to heat a cleaner air, and this hot air will be used to generate electricity with a turbine. To generate electricity, we have also other cycle as the well-known Rankine cycle. It basically uses the water to generate electricity. But the trouble with the Rankine cycle is that it requires to make water boil, and sometimes it's not very easy to generate electricity with the Rankine cycle. That's why the scientists came up with a solution. It was to change the working fluid with an organic fluid with a lower boiling point. It's called the organic Rankine cycle. Another idea to fix that problem is the Kalina cycle, which doesn't use a pure mixture anymore, but it used a mixture of two components. In general, it's ammonia and water. And it's a very nice solution because we can control this process very efficiently, because as we have control over the concentration of ammonia, we can control the boiling point as well. And it's also a bit less expensive than ORC, but sadly there are very few providers for now because it's a new solution. Now, as other more specific solution, we have thermoelectricity. It's the same principle as temperature captors. Temperature captors are producing a differential tension when there is a temperature differential. But instead of using this differential to know the temperature, we could use it to generate electricity. We could also use the piezoelectricity effect, which is the same but with the pressure differential. Another very specific solution is the thermophotovoltaic. I think it's very important to check this idea, because I think it's the only thing I met during my research concerning about getting energy from radiations, and very hot process are emitting a lot of radiation, so it could be interesting to check this process. It's work very similar to solar panel. And now, as a very more specific solution, we also have the hydrogen regeneration. So it used three endothermic reactions. That's where we will need to get the energy to make these endothermic reactions work. And it's a very nice solution because, as you can see, it requires copper chloride, but it's very nice because the copper chloride we need for the first reaction is we get it back at the last reaction, so it doesn't produce any waste. We can also see the hydrogen generation is in red, but there is also power generation here and here, because the hydrogen generation wasn't taking all the energy. So it shows that it is possible to combine different methods to harvest energy when one method isn't enough. Now, if we go through my internship I did this summer in a pulp and paper company, the heat rejected is at a quite lower temperature, as you can see. The water is at 250 degrees Celsius. So if we take as an example the lime kiln, I was impressed because there was a very easy way to save energy. So we have here lime kiln, so it requires a lot of heat to transform mud lime into good lime. So there is exhaust gas coming from the left, and once the heat is taken, the exhaust gas are leaving on the right. And as we don't want the heat to leave too fast the kiln, they had that chain just before the exit, and the chains will just like absorb the heat. And as the kiln is rotating, the chains will dive into the mud to dry it. So I think it's a very interesting solution because it shows that it just requires chains to save a lot of energy. But the heat leaving, the gas leaving the can is still hot. That's why I checked to make a Kalina or organic Rankine cycle at the end with the exhaust gases. But sadly, it's not interesting economically. Now I wanted to check also another solution. The effluent at a very low temperature, it's the 30 degrees Celsius, but the flow is very high, making a very high power available. Even it's not that hot. I think it's pretty interesting in winter, but it's very hard to harvest this energy, and the only solution I found is using heat pump. To a heat pump allow to get energy for a source to give it to another medium, but we need to give it electricity in exchange. It may be not interesting depending on the context, but I think we are in Quebec and we have a very good position containing electricity. I think it could be a good solution to use heat pump to harvest energy, maybe to heat buildings, for example. We are already using heat pump to heat building with cold air or with cold water at 10 degrees Celsius. So it could be very efficient with water at 30 degrees Celsius. And here a small chart I got from Hydro-Quebec giving the efficiency in function of the difference temperature between the heat source and the medium we want to heat. And as you can see, if we want to heat buildings with with water at 30 degrees Celsius, we would have a very nice efficiency. So I think it could be a good solution to save energy. And now if we go through the conclusion, I think it's a very nice idea to have common solutions to reduce our energy waste. But as we saw with the chain, I think it's also very important to always think outside the box, because sometimes the best solution might not be the one we have in mind. And if we can reduce our energy consumption, it will be very nice, because it will help to prevent the global warming, but also to save a lot of money for the industry. And if we want to end on the nice slide, I wanted to show this little graph we saw at the start, but I added some data. The red cross shows the 2002 prediction concerning our energy consumption. And as you can see, we are under this consumption. So it means that we are already working on reducing our energy consumption, which is very nice. And it's over for me. If you have any question.
Thank you, Thomas. Thank you so much. As we have a tight schedule and we have many presentations today,
Yeah.
I suggest that we have a discussion in the chat if required, and I'll move
Okay.
on to the next speaker, which is Vincent.
Okay, let's go.